So hi everyone, myself Rekha, Assistant Professor, Department of Mathematics. Today we are going to discuss about the topic bisection method in the course Computation Mathematics. So this is one of the numerical method to solve the algebraic and transcendental equation. For example, cos x log x, x cos x, x log x, or else higher power of x power 3 minus 2x plus 1, etc. Then we can go with the bisection method. So what is mean by bisection method? We are going to see the contents, what is bisection method, one example problems, and some of the more problems also we are going to discuss in the bisection method. Before entering into the bisection method, first of all, what is bisection method? You are going to find the roots, and also it is an iterative process, and we can repeatedly find the roots using the formula f of x equal to a plus b by 2. So before going to that, we have to find the interval, that is f of a. You have to find the f of a, f of b. If the root lies between negative and positive, means we can conclude there will be a two roots. And we have some of the tops. We have one example in this. F of x is equal to x square minus 1. For that, first of all, we have to verify f of 1 and f of 3. F of 1, if you substitute in the place of x, we will get 1 square minus 4, you will get minus 3. If you substitute 3, means 3 square minus 4 will get 5. So the root lies between minus 3 and 5. So the positive and negative. So the root lies between 2 and 4. Next we are going to substitute the iterative process, and f of 2 we are going to substitute. 2 square minus 4 equal to 0 means we will get 0. So here no need to adopt the bisection method because the root easily converges to 0. In some of the cases, the root lies between the value 1 and 2, and we have to adopt that method, bisection method. But this problem is luckily will get no need to follow the iterative process. So it may occur in some more cases. So next, if you go with the iterative process, what happens we will see. The next second example. That is f of x equal to x cube minus x minus 2. This is the root. Already they are given the root lies between 1 and 2. So if you substitute 1 means 1 cube minus 1 minus 2 means minus 2. 2 cube minus 2 minus 2 means 4. So the root lies between 1 and 2 we confirmed, because the root is positive and second root is negative. For the second root is positive. Now we have to adopt the bisection method. So what is the formula for the bisection method? That is first of all 1 plus 2 by 2, 1.5. Again you have to check 1.5. 1.5 cube minus 1.5 minus 2 will get 3.375 minus 1.5 minus 2, get minus 0.15. Next you have to go with the second iteration. So again the value of the second 1.25 is positive, so the root lies between 1.5 and 2. So 1.5 plus 2 by 2 you will get 1.75. We have to check 1.75. Whole cube minus 1.75 minus 2 means 1.609. Then we have to go with the next iteration. 1.75 plus 1.75 by 2 means 1.625. So we have to go with the 1.625 whole cube minus 1.625 minus 2 means you will get 0.675. So the root lies between the f of check f of 1.625. So you will get minus 0.125. Again the root lies between 1.5 and 1.625. So likewise we have to check the iterative process, and we have to continue the iterative process till the iteration will proceeds. So again if you go with the next iteration process means you will get 0.12, and finally we can repeat the iteration. So at least we can repeat the iterations till the convergent occurs. For example, if we repeat the iteration, we will get 1.521. More or less we are repeating the procedure as soon as possible. For example, up to 10 iteration we can correct the decimal to 4 decimal. So approximately in the 7th or 8th, 9th, 10th iteration, more or less you will get 1.521. Same value means we can conclude the iteration. So the root is, we can write it as 1.521. So this if you note, the bisection method means the primary is nothing but the calculation is just finding the mid value in each value, and it is one of the iterative process, and we have an some of the error also occurs in the bisection method. Between the interval, so this helps us to iterate converges quickly, and more value we can attain compared to the lengthy process only bisection method, compared to the regular fallacy and as well as the Newton-Raphson method. So next class we will see the Newton-Raphson method. So I will give more problems as an in SNS courseware as an assignment to solve the bisection method. So this is very important and repeatedly asked questions. So concentrate in that in solving the bisection method. So thank you for listening this video.